For conclusion, reference from textbook Thermodynamics and Engineering Approach, ninth edition by Jonas A. Sengel, chapter 11, page 627. The circuit that incorporates both thermal and electrical effects is called a thermoelectric circuit, and a device that is operate on this circuit is called a thermoelectric device. Thomas Seebeck, who made discovery this phenomenon, it is when heat is applied to one of the conductors and or semiconductors, heated electrons flow toward the cooler one due to a temperature difference between two dissimilar electrical properties, and that produce a voltage difference between the two substances that is known as Seebeck effect or thermoelectric effect, which lead to a thermoelectric generator where heat is transferred from a high temperature source to hot junction in amount of QH and is rejected to a lower temperature sink from cold junction in amount of QL. The difference between these two quantities is the net electrical work produced. So thermoelectric power cycle is closely resembles to an ordinary heat engine cycle, with electrons serving as a working fluid. Therefore, the thermal efficiency of the thermoelectric generator operating between temperature limits is analyzed by Carnot cycle efficiency. Thus, in the absence of any irreversibility such as heat loss due to the resistance of the wire. However, according to the result of this article, the research experimentally synthesize and fabricate pure carbon nanotube yarn as a thermoelectric generator and compared three different structures. First one, traditional stacked. Second is disordered single wall carbon nanotube sheet. And the third one is aligned carbon nanotube sheet interconnected by the silver. So the last one, they use the technique called floating catalyst chemical vapor deposition, which result in fabricating a flexible long single thread carbon nanotube yarn and highly aligned structure, which then can be used multifunctionalized with positive and negative legs and electrodes without additional deposition process required. And that significantly results in minimize the circuit resistance, which is one of the irreversibility, and that enable high performance and mechanical properties, stability, uh, that compare with the other two, disorder and traditional stacked ones. So this type of carbon nanotube sheet are considerably outstanding in electrical and mechanical properties, such as lightweight, flexible, and high electrical conductivity, which are suitable for thermoelectric application. For instance, a wristband prototype yield maximum power output of 8 microwatt when exposed to 50 Kelvin temperature gradient, and the density is about 0.4 gram per centicubic meter. This demonstration implies that we can use this wristband to convert heat from our body directly to electrical power or electrical work without any moving parts and components except the wristband. So the wristband device functionalizes as thermoelectric generator or a heat engine that converts heat to electrical energy due to the thermoelectric effects. Conclusion, reference, and thank you for your attention. Please leave comments and questions. Thank you very much.